Variable length subnet masking. Vlsm has become the preferred method for subnetting, most commonly used when a business or enterprise purchases a network of IPv4 addresses. Network administrators will create subnets for a variety of reasons, security and management foremost. You have already studied about network size based on the number of bits used. In the assignment, the original network is 192.168.0.0 with a prefix of 24. This means 24 network bits and 8 host bits. In binary, it looks something like this. Each host bit represents an IP address. One octet represents these values: 128, 64, 32, 16, 8, 4, 2, and 1. Since our numbering begins with 0, this full octet represents 256 addresses. The network address and the broadcast address cannot be assigned, so there would be 254 assignable addresses. Subnetting would take this network and make smaller subnetworks. I've developed a chart to summarize the facts for the last 3 octets. Looking at the 4th octet, the range of addresses begins at 1, reading from right to left. As the values increase, notice they double each time. This is because the binary sequence exists in powers of 2. Notice the prefixes increase by 1, moving from left to right, as each adds 1 more bit to the network, which in turn decreases the range of host addresses. Moving down to the bottom, first we notice that the first octet would have 8 bits and the prefix would be a /8. As we move to the second octet, for the first bit we would have a /9, a subnet mask of 255.128.0.0. On my chart, an X represents 255. Our range of addresses would be 128 in the second octet. That would be a total of 8,388,608 addresses. If all bits in the second octet are used, the prefix would be 16, 8 from the first octet, 8 from the second octet. So 1 bit from the third octet would be a prefix of 17, and so on until all the bits in the third octet are used for a prefix of 24. Into the fourth octet, we come to prefixes /25 to /32, though recognize that /31 and /32 cannot be used for subnetting. /31 would only have 2 addresses, and since the network and broadcast addresses must be reserved, this prefix would not yield any host addresses. I will make this chart available to you under Student Resources on the NetAcad site. You can use it for reference, but keep in mind you will not be able to use it in exams and certifications. My strategy when taking an exam is to take the blank paper that's provided and recreate the 4th octet to use for reference. This is a subnetting chart that I like to use to help me organize my subnetting. This will be on your first subnetting practice assignment. I will make a blank chart available under Student Resources. You see here a topology of a network and the requirements showing the number of hosts that must be accommodated. Always start with the largest number and list the number of hosts required. To that number, we add 2 for the network and broadcast to get the total number of addresses needed in the subnet. In our example, the largest requirement is 126. Add 2 to that, we find that the subnet size must be at least 128. This can be accomplished by borrowing 1 bit. This then defines our first subnet. The network address is never assigned to a host because it is the address that shows all the members of the network. The broadcast address, the last address in the subnet, is never assigned to a host. It is used to send traffic and requests to all members in the network. We add 128 to the network to get the next subnetwork address. Our next subnetwork begins at 192.168.0.128. To find the broadcast address of the first subnet, subtract 1 from the beginning of the next subnet, so we get 127. Borrowing 1 bit gives us a prefix of /25, that is 24 bits from the first 3 octets plus 1 bit from the 4th octet, and that is the subnet mask of 255.255.255.128. We can add in the first usable address by adding 1 to the network address, and the last usable address is found by subtracting 1 from the broadcast address. The next largest host requirement is 30 hosts. Adding 2 for network and broadcast, we see that we need at least 32 addresses. Borrowing 3 bits from the network will give us the range required. This gives us a prefix of /27 and the subnet mask of 255.255.255.224. That 224 comes from adding the values of those 3 bits that are borrowed, 128 plus 64 plus 32. Now add 32 to this network address to see that the beginning of the next subnetwork will begin at 192.168.0.160. Now we can complete the first usable address, the broadcast address, and the last usable address. The next largest subnet requires 18 hosts. Adding 2 means that at least 20 addresses are needed for this subnet. What range would have to be used to accommodate this number? Always choose the range value closest to that number without going under. In this instance, our range is also 32. 192.168.0.160 plus 32 gives us the next subnetwork of 192.168.0.192. Now, complete the information for this subnet. Next, the 4-host requirement plus 2 gives us 6. The closest binary value without going under is 8. We will borrow 5 bits from the original. That means a prefix of /29 and a subnet mask of 255.255.255.248. 192.168.0.192 plus 8 equals 192.168.0.200. That's the network address of the next subnetwork. Now complete the information for this subnet. Finally, for the 2-host requirement, 2 plus 2 is 4. Needing a range of 4 means borrowing 6 bits for a prefix of /30 and a subnet mask of 255.255.255.252. Here, I go ahead and add 4 to my network to be certain of the next subnet address and what the broadcast address will be, but that's all I need on this line. Completing now this row, notice that our range is 4, so there are no gaps in these addresses. And now the chart is complete. I developed this chart because I like to easily reference my first usable and last usable addresses. Conventionally in a simple network, but not always. The default gateway is assigned the first usable address, and the PC is assigned the last usable address. As we do more practice, we'll progress to subnetworks that require greater numbers of hosts, moving into the 3rd and 2nd octet. Remember, email me with any questions.